How deep should be an earth rod be? So in many cases you find that the earth rod is probably around 3 to 4 feet. Okay, so the depth will definitely be dictated by the earth rod. So that is a very good question, our top boss Margaret. So again, remember the earth rod requires to have that clamp where the earth cable is attached, and therefore that is where we usually have what is referred to as an earth pit or an earth inspection. Initially it was directly above the ground, but what we are trying to avoid is to have that directly above the ground, but instead have a wall where you will have an inspection point, so that even the moisture or the rain, the impact of the rain will not be direct on the pit or on the earth inspection pit or point, but instead have it on the wall, so that we can reduce the impact. Clearly that the earth is a good conductor of electricity. There are factors that can cause the earth to be a good conductor of electricity. All right, so if these charges are redirected to the ground, what is the ground supposed to do with it? So once these charges are into the ground, they will find their way back to the source, which is the transformer. All right, the TX. So if this is a charge, let's have it pause, or is it negative charges? Yeah, so if we have these charges going all the way back to the transformer, it will go all the way to the, especially if it is a 3-phase transformer, right? And at the output we have a Y, and of course we have this common point. What is the name given to this common point? X. So if I may have this one 2 and then this is 3, so this one I can also have this one right here, and so we can as well have this at this point. What type of a connection is this at the transformer? Yeah, what type of a connection? Let me know if you understand that, my top bosses. So at the transformer, what we do have right there is what we refer to as a delta, and then this one is a star connection. At the center here, what is this? I have 1, 2, 3. All these are lines or live, or this is a phase 1, 2, and 3. All right, so this one is a delta, this one is a star connection. So at the secondary we have this one as the neutral. So this middle point here, or the connection at this point, is definitely the neutral. So that definitely is where we get our neutral connection from, making it a delta star connection. And why is that important? It is because assuming that we require a single phase, we require a phase, and then we will require a return point, that is a neutral, so that we can complete the circuit. Top boost. Okay, that is not a good representation when it comes to electrical, but my point is electricity comes from somewhere, and then it goes through the appliance or the load, and then it goes back, and that is how a circuit is completed. So assuming that this one is a load, right? It could be a bulb, a microwave, a heater, whatever it is, but a load. So this one is the phase or the line, and then this one is the neutral. It has to go back. Now you may ask me, John, where does earthing comes to play? What is the importance of earthing? How does it come about? Earthing is very, very important, because at this point where we have that, we are definitely going to have something that is very, very important. If let's say we have a microwave here, so I'm just trying to come up with an image. This is definitely our microwave. So that is the screen where you can watch your sandwich burning, and this one is plugged to the wall, isn't it? Plugged to the wall at 220 volts. So we have something that is very, very important, like I was talking about here. This is the load. So we have the phase or the line, and we also have the neutral. The earthing for this microwave will only work only and if only the connection of this metallic surface. So you already know that this is the metallic part of the microwave, right? Is connected to the socket or the wall outlet, so that this cable, which is coming from the microwave, has 3 pins, which is line or phase. And it also has something that is very, very important, which is definitely earth connection. If those are missing, then it means there is a problem. This is a heater. This is a heater. This is a top plug. Assuming that this one is a microwave with this top plug, earthing has to be very consistent from the cable itself. So this one being a top plug, if you understand this basic, as much as it is a very simple concept, you will generally understand earthing. All right. So this is a top plug. This top plug is connected to a cable. In fact, let me just use this one right here, my top bosses. Okay. So we have this cable. This is the best way to understand earthing. The coil itself will definitely be connected to a plus or opposite. No, the coil itself is connected here through these two pins, so that once the current is flowing through it, we have the neutral as well as we have the phase or the line. And that is why here we have this indication that this is L, this is N. What does that mean? Line, neutral. And then, of course, this one is indicated E. You see there? Are you able to see that? That one is an E, meaning earthing. And you can see it is longer than the other pins, so that when you insert it inside a wall socket or inside an extension cord, it will definitely pave way for connection. It will first be connected. And so today, my top boss, we are diving deeper when it comes to this subject. So this pin is longer, so that when it is connected in the walls, it will first of all make contact with the connection here, the earthing connection, which is this one, before you can even connect this heater. If, for instance, someone accidentally comes in contact with this heater, already the earth pin or earthing pin has made contact in there. You can even see, my top bosses, that this one was intentionally made to be at almost at the surface. You can see the is it, let me not say the mabati, but you can see that inside. I don't know whether you're able to see. You can see that copper-like part inside right here. All right. And for the other two pins, you cannot see that. Why? Why is that so? So that when you insert this plug inside there, you see which one goes in first. It is definitely the earth pin for safety purposes. So once it goes in, it is already in contact right there. So if you plug it in, my top boss, it has already made contact with what? The earthing connection. Is that so simple to understand? I believe it is. Once it has made contact, it means that the protection is on. But like we said, if this cord is not in contact with the metallic part of the microwave, just the same way, if that connection, that pin, is not in contact with this part here, you see this part? So this one acts as the earthing or the safety net. So it is connected with this earthing pin. So for us to just prove that, we will definitely test. And so here I have my digital multimeter. What we need to test here, simple, is to test the continuity. So from the plug, once the plug is inserted inside the socket, it is supposed to make a continuity all the way up to this part here. So what I'm going to do, my top bosses, is to simply remove this cover on the top plug, so that we are able to record the continuity. So using my tester here, I'll simply unscrew that, and then boom. Oh, everything pouring down now. So I'm going to share more on the features of the top plug, but for this screw, we are supposed to have it right there. This is the best class that will help you understand the basics when it comes to electrical. All right. So these are just the screws for what we have been talking about. This is definitely the earth connection. This is the line, or the, you can see even the fuse. The fuse is attached to the line. It is not attached to earthing or neutral, simply because this is where the connection from the face gets in, and then this is the neutral. This is the earth connection. Now, my point was that that pin, the earthing pin, is intentionally longer, so that when it gets to the sockets, this is the socket. When it gets to the socket, it will first of all make contact right there. So we want to test, in fact, even before the other pins get in, all right, will we get a continuity? All right, so like that, you see, it is not already in, but we want to prove, is it already making contact with the earthing connection? So using our digital multimeter, that is what we are going to do. Let us first of all agree with me that this is what we are going to do. We're going to unscrew that and then have to attach one of the probes right there, and then at the back. So let me just demo it from the front of our camera. So I can simply attach it at this point, and then all that we need to get is a beep. So you get a beep. Yes, it is in contact. And mark you, the pins, these other two pins, are not yet in contact with the, are not yet fully inserted in the socket. So that is what we have. The moment we insert it like so, and then record the, in fact, even when the switch itself is off, and then switch it, before we switch it on, record the continuity between this earthing point here and this earthing that is in the socket. Should we get a result of continuity? Will it beep, my top bosses? So that is what we are looking for. And how are we going to do it? Procedurally. So this is my multimeter. So we want to get some zeros and a beeping sound, so that we know that there is continuity. So we will test between this long pin, or the earthing pin, and this part right here. So we'll simply insert it like that, and trust me that we have connected it there, and then go ahead and touch that, and what you can see is a beep and also zeros, meaning very little resistance, almost negligible. Thank you so much, my top bosses, for watching this. I have been your host, John Gatehi, and on behalf of our top bosses who are definitely working with us here at Top Heights, I really appreciate you. I appreciate your time. Thank you so much. Goodbye for now. This is Top Heights Electricals and Solar. Have a fantastic time.